Okay, so far we've introduced rules that apply when you have a universally quantified statement, and you can get rid of the quantifier. And we have a rule that applies when you want an existentially quantified statement. So if you don't have an EX, you can get one. Now we're going to look at a rule that applies when you have an existentially quantified statement. And warning, the book does it one way, and the proof checker we've been looking at does it another way. So I'm going to show you both ways, and hopefully by seeing two ways of laying out the proof, it will help you understand how the proof is supposed to work. I don't know. I'll try to make it as clear as possible. So let's do it the textbook way first. We'll interpret the predicates as we have been doing. This sentence says all humans are mortal. This one says something in the domain is a human. And then it follows from those premises that something therefore must be mortal. If something is a human and all humans are mortal, then something must be mortal. So how can we prove that? One thing we don't want to do is just pick a specific individual from the domain. For example, from the fact that something in the domain is a human, it doesn't follow that some specific object, let T be Tanya, is, or A be Aristotle. It doesn't follow that some specific thing from the domain is. And we could end up inferring something false from these premises if we just filled in any old thing we wanted to. We can't do that. So what we will do, doing it the textbook way, is instead of using P to be an ordinary name, we'll take letters from the middle of the alphabet, like PQR. I mean, maybe T would have even been included. From now on, letters from the middle, starting with P, PQR, the most common ones used. We're going to let these be names for some arbitrary individual. We don't know which one exactly. So instead of saying like this stands for Pete or whoever, this is the individual such that this is true. This says there is some individual, let P be whatever individual that is. I'm not naming a specific one. And there are some rules. You can't choose a name that's already in play. So if we've already introduced an arbitrary name, you can't use the same one twice. This is supposed to be, let us be referring to whichever one that is. I know not what. This is a new name. It's an arbitrary name. Okay. So given that rule, here's how the proof will go. P is whichever one makes 2 true, essentially. So let's cite line 2 and our new rule, which is existential instantiation, is the long name that we get in the book. The name that is used in the proof checker is existential elimination, or EE, because you had an existential and now you don't, you eliminated it. Okay, so now that we know that P, whatever that refers to, is human, now we can use that other rule we have to infer the conclusion. Well, first we have a step in between though. So we know, given premise 1, that if P is human, then P must be mortal because of premise 1. And so we'll cite line 1. And the long name is universal instantiation, or in proof checker language, universal elimination. We had a universal, now we don't. And now just plain old modus ponens, we get P, whatever it is, must be mortal then. So 3 to 4, 3, 4. And you could write MP, you could write out modus ponens. And that's how the book does it. And the proof checker does it a different way. Arrow elimination. And now we've established that whatever this P is, it would have to be mortal. If it's human, and all humans are mortal, then it would be mortal. So we know that something must be mortal, because this P thing, whatever it is. So at least one thing is. And we'll cite 5. And this time we used existential generalization to use the long name from the book, or the short name from the proof checker is existential introduction, EI. We didn't have one, and now we've introduced one. And that completes the proof. Now, we have to do it in this order. You couldn't have done this step first. Let's take a look at what that would look like. I'm going to copy and paste this. I'll put this back in a moment, but let's say we'd done this. There's nothing wrong with this line. It follows the rule, so there's nothing wrong with this line. But then when you apply our rule for existential instantiation, or EE, you have to choose a new letter. You can't choose P because P is already in play, so you'd have to choose like Q, and now we can't do modus ponens. Okay, so that's the book method for ensuring that we don't derive something false. We have to put limitations on how to name the arbitrary thing we're talking about, the something, whatever it is, so that we don't derive something false. And that means sometimes you have to jump through some hoops to follow that rule correctly, especially by making sure you use it before you use universal instantiation in proofs like this. Okay, now let's learn how to do it the proof checker way. It'll be really similar, but instead of saying, let's just all agree that letters from the middle of the alphabet are an arbitrary name. We aren't naming some specific thing. Instead, we're going to make that an assumption. Let P be the thing we're talking about here. First, let's put it in to the proof checker. So let's put my premises in and separate them with comma or semicolon. Let's put the conclusion in. Let's make sure we're in first order. Create the problem. All right. Okay, so instead of creating a new line and starting with, let's let P be such an H, we don't do that. We start a subproof. So here's a subproof option. Let P be such an H. Same exact line, it just is an assumption now. Let's assume P names the H we're talking about. And then we're going to do everything else the same. So we'll create a new line. I click to the new line button. I'm going to use the universal instantiation. So remove the quantifier, change the bound variable to the name, and it's totally fine to pick P because this says everything that's a human is mortal. So whatever P is, if it's a human, it's mortal. 1, universal elimination. New line, plain old modus ponens. 3, 4, the shortest way to type in the justification is arrow elimination. And now that we've established P, whatever we're talking about here is such an M, we can get, so something is an M. And we'll justify this 5. And this is existential introduction or existential generalization. Okay, so here, so far, everything is identical. The only difference is we made that first line an assumption, which we don't have to put any like, this is my assumption for existential instantiation or whatever. You just write the assumption. Now we're going to finish the subproof and add a line. So that's how we say we're done here. The next line will be, it'll be exactly what we ended with. And here's how we cite the existential instantiation rule. I'm looking at line 2. This was the existential I started with as my assumption. So I'm looking at line 2, and then I assumed we were talking about, like, let's call it P. And here's what follows from talking about this random P. I got to something that we're not talking about P anymore. I've discharged this assumption I was talking about P. So I'm going to cite the subproof, line 2 and the whole subproof. So 2, 3 through 6. Every time you use EE, existential instantiation or existential elimination, you are trying to get rid of the existential you had with. This time we still ended up with one, but it's like we're trying to get rid of it. Every time you use this rule, you're going to have one line, comma, whole subproof. Okay, let's check our proof. Congratulations, this proof is correct. So this is how we use the existential instantiation rule. Now, what are the constraints on it? How did I know what to start with? How did I know how to end it? What's allowed, what's not? You can choose any assumption you want where you just remove the existential quantifier and you pick a name. Here, I don't think it even cares if you pick A, B, Z, whatever, because we're not doing the, let's just assume letters from the middle are arbitrary. Instead, we're saying like, here's our way of showing it's arbitrary. We're picking something as an assumption. So pick anything you want for here. Remove the existential and give it, put a name in, a term in instead of the variable. The only thing you can't do is choose a term, a name that's already been used in the proof. So that's satisfied. And then you derive whatever you can given this, and you cannot end with a statement that includes P in it. Those are the only constraints. P can't already have shown up in the proof, and P cannot be in the line you end on. And then the next line is the same as the end of your subproof, and that's how you cite it. Okay, let's look at another example. So here's another one from the book. And the point here is to show why it's so important that you can't reuse names when you are using the existential instantiation rule. So this, let's let T stand for is the teacher of your logic class. And let's let P stand for is the Pope. Sentence 1 says, someone is the teacher of your logic class, and 2 says, someone is the Pope. And this conclusion says, the same person is your teacher and the Pope. So essentially your teacher is the Pope. This shouldn't imply that, right? Each of these is true, but here's a scenario where the premises are true and the conclusion is false. Me, I'm your teacher, but I'm not the Pope. Even though this is true, someone is your teacher, me, and someone is the Pope, Pope Francis. This does not follow. So if we had a rule that allowed us to do this, we would be able to derive something false, and that's bad. So what's the this? From line 1, EX, TX, let's say I were to say it, let P be such an object from the domain. And I said we're going to only use P, Q, and R, so let's do P. Let P be the name of whoever it is that's your teacher. And let P be the name of whoever it is that is the Pope. From this, it follows TP and PP. So we have been allowed to derive something false from something that's true. And if a rule allowed us to do that, that would be bad. The fundamental feature of our rules is that they are truth preserving. They embody valid inferences. If the premises are true, the conclusion must be true. If you apply our rules to true things, you are guaranteed to get something true. So this would be a bad rule. And all we are doing to fix it is say, this part was wrong. You can't do that. You have to choose a name that hasn't already been used, in which case the only thing you could put together is this. So this we can prove. Someone is the teacher, someone is the Pope. So let P be the teacher and Q be the Pope, then that person is the teacher and that person is the Pope. Nothing wrong with that. You might be wondering, like, what if the Pope is the teacher? Is that inconsistent with this? No, because sometimes you can have two names for the same thing. Minor detail for our purposes, but our language allows us to have multiple names for the same thing. The only thing you can't do is have one name for more than one thing, because that would introduce ambiguity. We assume our names pick out one thing. Okay. Next point, can we do this in the proof checker? No, we can't prove this in the proof checker in the same way that the author proved it in the book, because the rule operates differently. If we were to leave P and Q here, because this is an arbitrary instance, it's like ending with an assumption open. Okay, so assume someone is your teacher and someone is the Pope. Let P be whoever it is that's the teacher and Q be whoever it is the Pope. The conclusion is some arbitrary thing is the teacher and some arbitrary thing is the Pope. And the proof checker will treat that as like having an open assumption in your proof. You just won't be able to do that. Before I said the last line of the subproof can't have P in it. To end it, well, the conclusion has the P in it, so there's no way that you're going to end on this. This is kind of a weird conclusion because it has these arbitrary instances in the conclusion. You are not going to see any problems like this in the problems in the textbook or elsewhere. This was really just to illustrate a point about why we demand we choose different names when using this rule. Okay, let's move on. Here's a fun one that's a little longer, and we'll do it together, and we'll do it using the proof checker. I recommend, as usual, that you pause and try to do it on your own and do it using whichever method you prefer, working it out by hand, putting it in the proof checker. And if you put it in the proof checker and it works, then you don't need to watch me walk through it, but I will think aloud as I do it. So try it on your own, come back when you're done, or if you get stuck, if you want. Okay, how will I get started on this? This is a lot. There's a lot to see here. As always, my number one piece of advice is to pay attention to the main operators and quantifiers of both what you have and what you want. What I want is an existentially quantified statement. One way I get those is by using existential generalization or existential introduction. And to use that, I would need to have this, but where this is a name, on its own line. And I see I've got some stuff in here where maybe I end up getting these on their own line at some point. Okay, well, now what do I have? I have universally quantified statements, so I could immediately just start applying the universal instantiation rule, the AE elimination rule, and get like, well, let's use this, then let's use this. But I also have an existentially quantified statement. And if I want to get examples of fx and hx, which, look, those are antecedents of conditionals here to use modus ponens, so I'm probably going to want to get these on their own line. Do existentially quantified statements first, because if I do these first, when I do an existentially quantified statement, I have to choose a brand new name, and then it won't play well to do modus ponens. So rule of thumb, anytime you have a statement, not want, but have a statement with an EX out front, do that rule first. So let's do it the way the book does. Okay, so we've got EX, FX, and HX. We're going to remove the existential and then just let P be an object that makes it so that this is true. Whichever object that is, I don't know. And let's justify it to, and instead of writing out existential instantiation, I'm just going to use the proof checkers shorthand. Okay, now what? Now I can take it apart. Obviously, that's something I could do. FP, anytime you have a conjunction, you could take it apart. So for simp, okay, now what? Well, I said before I could use the universal instantiation on these lines. I just needed to do the existential first. Well, let's do the universals now. Let's start with this one. We'll remove the quantifier and replace the bound variables with names. And here we can reuse because this says everything in the domain. If it's an F, it's a G. So whichever thing P is, it will be a G if it's an F. So let's cite one, and we used universal instantiation or universal elimination. And then let's just do the other one first, even though we could also start doing modus ponens and stuff right now. Let's do this one. And let's use the same name, obviously, so things work together. And this one was line 3, same rule. Okay, now we're doing modus ponens. I have a conditional statement. Here's the antecedent. So I can get the consequent. And which lines am I looking at? Lines 5 and 7, modus ponens, or to use the new code from the proof checker. Okay, what else do I have? Here's another conditional. The antecedent is HP, so I can put IP on a new line, citing lines 6 and 8 MP, or our new way of abbreviating the rule. All right, now where are we? Recall, we're trying to get G something and I something. Well, we've got GP and IP, so let's put it together. So that's just 9-10 conjunction, or to use the new proof checker shorthand conjunction introduction. We didn't have one and now we do. And finally, we can use existential generalization or existential introduction on this line. We've shown that something is G and something is I, so there exists something that is both G and I. That is 11, existential introduction. Okay, so that is how we would do it using the textbook method, where we just know that when we use a letter from the middle of the alphabet, we're talking about an arbitrary instance. So now let's do it the proof checker way with subproofs. Okay, let's go back and put some semicolons in here. Okay. So just like last time, we're going to do it exactly the same way. We just have to, instead of going straight to this, we have to do a subproof. It's more complicated. So new subproof. I'm just going to remove the quantifier and put in names just like I did before. I don't need to justify anything. That's just my assumption to get started, then new line. And now everything is going to go the same as before. So let's do FP, and I'm going to sketch it in and then go back and justify it. HP, break apart that conjunction. We're going to use simp on those. Okay, what did we do next? Then we used universal instantiation on these two things. So let's do that. Let's put P in. Okay, we did that. Then we do a series of modus ponens steps. So lines 5 and 7 get you to GP, and then lines 6 and 8 get you to IP, and then we put them together into a conjunction. So we've got, which order is it in? G first. It's got to match the conclusion, so order matters. GP and IP. And then finally we get the conclusion. Then we end the subproof and we put the thing on a new line. We chose a name that has not been used before. We used rules correctly. We ended with a line that does not include P, so we ended the subproof and then we put the last line on a new line. Now we just have to fill in the justifications. Okay, so this is going to be for simp. Oh wait, we can't. Is simp still the one? Nope. Conjunction elimination. So for conjunction elimination. Then we used universal. So 1 is AE, and then this one is 3 AE. Then we did our modus ponens steps. So this was 5 and 7. And this one was 6 and 8. This is 9, 10 conjunction or conjunction intro or injunction. And then existential generalization from lines 11, existential intro. And that's the end of the subproof. And so now we get to justify this. We looked at line 2, so we cite line 2, and then we did this subproof 4 through 12 using the existential elimination or existential instantiation rule. So let's check it. Yay, this proof is correct. Now, because this one is more complex, if you struggle to get the subproof bit right, but you feel like you understand well enough how to just do it this way, you can do it this way by hand, and you'll be allowed to either type up your answers or submit them by hand. But as I said before, this method is worth learning because then you can check your work. And anytime that you'll need to use this rule, which should come up in many of the proofs, you'll want to be able to check your work, but it's up to you whether you use the proof checker or not.